Hello again, ladies and gentlemen. Welcome to Bonus Station B, which is about factoring quadratic equations. You'll notice that I have my handy dandy calculator out and ready. You might want to get your calculator set up so that you can use it while I talk through this first example as well. The way that I like to think about this station, about factoring quadratic equations, is that we are going to do the opposite of what we did in Bonus Station A. So in Bonus Station A, you started with two binomials that we multiplied together to create a quadratic expression. In this case, we're going to use those same skills, just in reverse, to figure out what the factors of this quadratic equation could be. So in this example, you'll notice I have x squared plus 13x plus 40. We want to know when this equation equals 0. We want to find the x-intercepts, or zeros, of this equation. So the first thing that I need to do is factor it into its two binomial factors. So I'm going to set myself up with two sets of parentheses, just like I saw in Bonus Station A. The first thing that I'm going to do is look at my first term. My first term is an x squared. In order to get x squared, I must have multiplied an x term times another x term. So setting up the beginning is pretty quick. I know that I need to have x times x in that first distribution or first part of my window to result in an x squared. The next thing that I'm going to focus on is the last term. I need to figure out what two numbers, this term right here and this term right here, what two numbers did I multiply together to get a positive 40. So what I like to do is come over on the side of my paper and list out the factors of 40. I have a lot of options, so I want to make sure that I have all of them listed and ready for what I'm about to do. So if I'm thinking down my line, I could do 1 times 40. That would result in an answer of 40. I can do 2 times 20. I know that 40 is not divisible by 3. You could always try it on your calculator if you weren't sure. That's not going to give me a nice number, so 3 is not a factor. I could do 4 times 10. I could do 5 times 8. I'm just working my way up. 40, again, is not divisible by 6. I could double check that if I needed to. And 40 is also not divisible by 7. 40 is divisible by 8, but you notice we already have an 8 in our table, so we don't really need to circle back and do the opposite of these factor pairs. So now I have all of my options, all of my factors that would multiply together to give me a product of 40. Any of these combinations would give me a product of positive 40. The next thing that I need to do that's going to help me make my decision of which pair of factors I can use is look at this middle term, this plus 13x. If you remember, when I was doing my multiplications, I always ended up with those two terms in the middle that both had an x, that I could combine the like terms and get that 13x as a result. So I need to figure out which of these pairs would give me a sum of 13. When I add them together or combine them, which one would give me a sum of 13? It's not 1 and 40, or 2 and 20, or 4 and 10. In this case, it would be my pair of 5 and 8. I know that 5 plus 8 gives me an answer of 13, and 5 times 8 gives me an answer of 40. So I know that I can get both of those numbers that I need by using x plus 5 as my first binomial and x plus 8 as my second binomial. If you wanted to check this, you could do your double distribution or your window or box method to make sure that you're getting the quadratic expression that you want. I often take a minute to do that, so I'm going to show you that now. Just quickly, it's nothing major, but I would do x times x. I would get x squared. X times 8 would give me plus 8x. 5 times x would give me plus 5x. And 5 times 8 would give me 40 like I wanted. I could double check and make sure I can combine a positive 8x and a positive 5x to get a positive 13x. And I've checked and made sure that I do get that quadratic expression that I wanted. X squared plus 13x plus 40. So it's worth it to take the 30 seconds and just double check. If something's not working out, you might just have the wrong factor pair. So it might just take a few tries. You can always go back and try another factor pair if something's not working out for you. All right, so that is most of the work. Now we just need to decide when this equation is actually going to equal 0. I know that anything times 0 is going to equal 0. Multiplying something by 0 just cancels everything out and makes everything disappear. So in this problem, I could have x plus 5 equal to 0. That side could equal 0. Or I could have x plus 8 equal to 0. Notice that I took both binomials, this side, and set each piece equal to 0. These are just quick one-step equations to get x by themselves, so I can solve to get that x could be negative 5. That's one of my zeros, or x-intercepts. And similarly on this side, my x could also be negative 8. So those two numbers are my two zeros, or x-intercepts, of this equation. I factored it first to figure out what my binomials were, and then I set both my binomials equal to 0 to figure out my two roots. If you want to check this, this is an amazing time to use your graphing calculator. This is a really great tool. I'm going to type in my original quadratic equation. So I'm going to have x squared plus 13x plus 40. I'm going to graph it, and I'm going to kind of zoom in to make sure that I have the zeros that I want. In this case, I see my quadratic equation crossing the x-axis at negative 8 and negative 5. So those are indeed the two zeros, or two roots, or x-intercepts that I wanted. So I know that I'm correct. You also can use your graphing calculator as a great tool if you're having trouble finding the factors. You can always type it into your graphing calculator and let the graphing calculator help you find the factors that you need. All right, it is that time where you need to try one on your own. So go to your worksheet. We gave you a new quadratic equation. It says m squared plus 7m plus 12. So get your parentheses set up. In this case, we're using a variable of m, but that's okay. There you go, you're all set up now. I want you to find your factors of 12 and figure out which one will give you a sum of 7. Good luck. All right, I hope that you're ready to go. You have your two zeros and you're ready to check. So I set up my parentheses for you. I have my two m's. I know that m times m would give me this m squared term. So I started there. Next, I need to find my factors of 12. I could do 1 times 12. I could do 2 times 6. Or I could do 3 times 4. So I'm going to look at that. I realize that 3 times 4 in this case is the pair that I need. 3 plus 4 gives me 12. And 3 times 4, 3 plus 4 gives me 7, gosh. And 3 times 4 gives me 12, sorry. So I'm going to add m plus 3 and m plus 4. I can double check, do some distributing. M times m would give me m squared. 3 times m would be 3m. 4 times m would be 4m. And 3 times 4 would be 12. I would combine the 3 and 4 m's to make 7m, so I'm feeling good about this. The last step is I need to set both sides equal to 0. So m plus 3 could be my 0, or m plus 4 could be my 0. I'm going to do some quick inverse operations to get an m of negative 3, or an m of negative 4. So this quadratic equation should have zeros, or x-intercepts, or roots, at negative 3 and negative 4. I'm going to do a quick check because I can. I have to use the variable x in this case because I'm on my calculator, but the letter doesn't matter. We know it means the same thing. And I'm going to move around on my graph until I can see that my quadratic equation is crossing the x-axis at negative 3 and at negative 4. So I'm all set. In a case where you see subtraction, you might need to work with some negative numbers or negative factors, so keep that in mind as you're working through your worksheet. If you need any help, just go to your teacher, let them know that you're stuck, and they'd be happy to help you. Have a good time.